a little bit of hands-on so that we can all at least have a feel of what it is or what the electrical installations are about. So these are the content or whatever we'll be covering. We are looking at the rules and the statutory regulations, the project settings or setting out, tools, names of common materials, electrical drawings, so and for that matter electricals. We have standards, or we have rules and regulations governing it, and there are several bodies that are focused on these things, and they come up with these rules, and we are mandated to follow them, enforce them, and make sure we save lives, properties, and whatever you can think of. We should prevent ourselves from hazards and all of that. It's not a bad thing though, but when you copy, you need to copy to suit yourself. Okay? So if you look at our regulations, mostly if you read the BS 7671, whether it's the British or the UK wiring, it's mostly like we just took it and then we brought it for us to use. Okay? You can see a block coming to fall on your head. You can see dangers coming by electricity. You can't, and you can't assume. So in electrical engineering, safety is at its what's highest. Okay? You need to always think about safety when you are working on electrical systems. So these are some of the procedures you go through if you want to work on, let's say, an existing installation. Let's say they called you, oh, my socket is faulty. First of all, you need to isolate that socket from the power, and then you work on it. I believe most of us know what it is, but for us that don't know what it is, let's assume this table is a socket, this table is a socket, this table, all of them are sockets. So from the consumer unit, let's say the DB, it comes here, we loop it here, we loop it here, we loop it there to the last table, and then it ends there. That's a radar circuit. Okay? For a ring circuit, it goes, and then there's a cable that's returned to the DB and comes to the same breaker. And we do that, we use that for certain reasons. One of them is when you are constrained or tight with spacing your DB and you have a lot of sockets that you need to do. You can do that because for ring circuits, you can do, it's advisable for ring circuit to do from 6 sockets going. For radar, up to 4 is fine. If you go 5, don't go more than 5. For ring, from 6 upwards, 6, between 6 to 8. Okay, the reason being that if for ring circuit, the advantage is that if there's a failure in, let's say, socket 2, okay, people on this socket, let's say socket 7, can still what? Have power. But for radar, for some reason, if there's a problem here, the subsequent ones wouldn't have power. A 3-phase system. In a 3-phase system, this is what we're doing. The black was still neutral here. Okay? But when you come to this, black is what? It's a phase. I don't know if you've seen the substations where we have the power transformer and transmission lines. They put an earth mat in all the areas under the ground, okay, and try to what? Create an earth. Now when that earth is created, when, let's say, there is the high tension cables, okay, when a cable, let's say, falls to ground, because those voltages are high, depending on the texture of the earth, when you step there, you can get a shock. So normally, this is a safety this thing for you. If you see something like that, you are not supposed to be walking. If let's say there's a cable that have fell down, high voltage, high tension cables, the 161s and the, let's say 35 kVA ones, you don't walk when there's a cable drop, because even though they've done the loop impedance test, we don't know which area is covering and which area is not covering. So we don't walk like this. What you do, you can hop. So your two legs together, you jump to the next stage and you jump. Why are we doing this? That's where the ripple effects come in. When it hit the ground, it's creating a ripple effect, and these effects, they are all at different voltages. Okay, so if I step here and the voltage here is, let's say 1 kVA, and the voltage here is 2 kVA, there's a potential difference. Now for current to flow, you need a potential difference. So if there's a potential difference between your leg 1 and leg 2, current to flow through you. But if I'm doing this, if I jump, I'm a 1 potential. If I jump, I go to maybe the next potential. I would, even though I'm being, I'm forming part of the circuit, but current will not flow to me. I'm just a voltage source.